Okay, this is Mark Cantrell. I'm doing a test video here. If it works out okay, we'll make this the video that goes on to Canvas. So what I want to talk about is Chapter 4, and this is probability and counting rules. So as always, we're going to follow the book very closely, and here we are. Let me make a little adjustment here, perhaps. Gotta bear with me, ladies and gentlemen, because this is the first time I've used this. Okay. All right, so here we go. So what we've got then is chapter 4 of the book. Hopefully you've got your book, and this is the outline. So the first thing we talk about is always the very first thing we look at is the outline of the book, outline of the of where we are in the book. Give me 1 second here. Okay, now I believe I can pause this. Let me pause it. All right, so I paused it, and hopefully that works. Okay, so here we go. So first thing we talk about is sample spaces and probability. The sample spaces is just kind of a generic overview of what's going on here, and a sample space might be, if you're flipping a coin, what can you get? You can get a head or you can get a tail. If you're throwing one dice, that's usually called a die, you can get a 1, a 2, a 3, a 4, a 5, or a 6. So that would be examples of sample spaces. Now, it's very helpful, we're going to see, to think about this in terms of spaces, otherwise known as like Venn diagrams is a term that perhaps you've heard, V-E-N-N. Venn diagrams, because then what we can do is we can look at the Venn diagram and we can get an idea of how things are going to be working out, and we'll talk about addition rules for probability. How do you add different events? There's two different rules basically. One is if the sample space has disjoint sets, and the other rule is if they don't have disjoint sets, if there's some intersection. Now, disjoint means, let me spell that, D-I-S-J-O-I-N-T. Disjoint means that there's nothing in common. So you might say a disjoint set might be, and I'm going to simplify, okay? The set of all people in this classroom that are right-handed and the set of all people that are left-handed, those are disjoint, because we say you're either right-handed or left-handed. Now, I totally recognize that some people are ambidextrous and can use both hands, but for the purposes of our illustration, that's what disjoint means. The multiplication rules and conditional probability, what that is all about, we'll see here, is when you have two events, one after another. How do you figure out what the probability is? So that's like saying, well, if I flip a coin 3 times, what's the probability of getting a head and then a tail and then a head? That's the multiplication rules. You multiply the probabilities together. Counting rules is very interesting. That's talking about the issue of how do you count? How many different ways are there of selecting out of a classroom of 14 boys and girls in the 5th grade? How many ways can I pick a team of 12 kids to be on the basketball team, or 12 kids to be on a tug-of-war team? The issue is, and the important distinction is, in a basketball team or a baseball team, the order counts. You are arranging them in a certain way. Whereas, on the other hand, if you're just picking a team of kids that go out there and do a tug of war, the order doesn't count. You're not arranging them in any particular way. And then, so that's the issue of counting rules. And then after we learn how to count, then we'll talk about how that applies to probability. And the basic idea here is that it's very, very simple to do probability if you're just counting. Like if I said let's say there's 50 people in this classroom, and there's 30 men, 20 women. So I would say, well, it's easy to count. I can count the men. There's 30 men. So the probability of randomly choosing a man is 30 out of 50. That's 3/5, otherwise known as 6/10, otherwise known as 60%. So it is really simple when you have a very simple example like that. However, it's not so simple when you start talking about these bizarre examples we have here in section 4.4, when we're counting how many ways can I select 10 defective parts out of 20 defective parts if there's a total of 175 parts. So it gets to be very complicated, and you can't do it with your intuition. We have to use these counting rules. So here's the objectives. I'm going to let you read that for yourself in your book. But that's kind of an overview of where we're going here, okay? And then, as always, the author tries to bring it home to something that's very useful to your life. And here's an example talking about statistics today and the probabilities of everyday life, okay? So let's read this together real quick. I'm hoping you're reading ahead, talking about probability as a general concept. What's the chances of something happening? I think I've mentioned before, it's very difficult to define probability. It's very easy to think about it, but it's hard to come up with a formal definition of probability that doesn't use the word probability in some way. So here is an example. Probability is the chance of an event occurring. Well, what is chance? Well, chance is the probability. So it's a real circular definition. We just do the best we can. It's not hard to figure out what we mean by it. It just means the probability. The probability means what is the likelihood? How certain are you that something's going to happen? And we'll talk about this in a little bit more detail here. We're going to talk about the various concepts. Okay, now I've frozen here. There we go. Okay. Okay, so that's the introduction. So I'm gonna discontinue. I'm gonna stop the recording here, and I hope it works out. If it did, I'll be posting this into Canvas, and I'll be doing lectures on all these other sections here.